All right, let's dive into one of the wildest, most mind-bending ideas in all of science, Heisenberg's uncertainty principle. Now, this isn't just some weird rule for physics geeks. It's a concept that shows us there are actual, fundamental limits to what we can ever know about reality. So, I want you to think about this for a second. What if the simple act of looking at something, of trying to measure it, actually changed it? It almost sounds like a riddle, right? But it's not. It's the absolute bedrock of the quantum world. To really get where this idea came from, we've got to jump back to the early 20th century. Physics was in chaos. I mean, the laws of the universe that everyone thought were set in stone, well, they were starting to crack. You see, for hundreds of years, classical physics was the undisputed champ. You could use it to predict the orbit of a planet, no problem. But the moment scientists started to look at the teeny tiny world of the atom, those reliable old rules just broke. They completely fell apart. Electrons were doing things that made absolutely no sense, and everyone realized the old playbook was useless. And this is the split they were facing. On one hand, you have the classical world we live in. It's like a giant clock. Everything is predictable, it's certain. But down in the quantum world of atoms, things get weird. It's all about probability and chance. It's less about knowing exactly what's going to happen, and more about betting on the odds. So into all this confusion steps this brilliant young physicist, Werner Heisenberg. He looks at this whole mess and thinks, you know what, maybe we're just asking the wrong questions. Maybe we need a whole new way of looking at reality itself. And here was his breakthrough idea. He basically said, hey, why are we trying to imagine these little electrons zipping around a nucleus like tiny planets? We can't actually see that path. He argued that physics should only care about stuff we can actually measure, like the specific light that an atom gives off. This whole idea forced him to create an entirely new type of mathematics to describe it, which we now call matrix mechanics. And it was from digging into this new math that his most famous discovery just sort of popped out. And it wasn't just a clever observation. No, it was a fundamental rule of the universe, a hard limit on knowledge, put there by nature itself. So what is the uncertainty principle? Well, you can think of it as a kind of cosmic trade-off. The more you pin down a particle's exact position, the less you can possibly know about its momentum, where it's going and how fast. And if you nail down its momentum, its location gets all fuzzy. You simply can't know both perfectly, ever. And this is the part that just blows your mind. This whole thing isn't because our lab equipment isn't good enough. Nope. You could have the most perfect, futuristic measuring device imaginable, and you would still be stuck with this rule. It's not a bug in our technology, it's a feature of reality. Okay, let's try a little thought experiment to see how this works. Say you want to find an electron's exact position. To do that, you gotta see it, right? So you hit it with a powerful little particle of light, a photon. Bam, you got it. You know exactly where it is. But that blast of light just sent the electron flying off in some random direction, so now you have no idea what its momentum is. Okay, try again. This time you use a super gentle, low-energy photon, so you don't mess with its momentum. Great, its momentum is stable, but the light is so dim you can't see it clearly. Its position is now just a blurry smear. See what's happening? It's a cosmic seesaw. The more you know about where the electron is, the less you know about where it's going. And it works the other way around too. You just can't have both. And that whole mind-bending seesaw effect gets boiled down into this one single elegant equation. Now don't let the symbols scare you. All this is really saying is that the uncertainty in position times the uncertainty in momentum can never equal zero. There's always this tiny minimum amount of uncertainty that you can never ever get rid of. So that little equation, it's not just math. It's a statement about how reality works. It completely shattered the old way of looking at the universe and built a much, much stranger one. Before Heisenberg, everyone pretty much thought the universe was like a giant, predictable machine. If you knew all the starting conditions, you could predict the future. The uncertainty principle absolutely destroyed that idea. It showed us that at the most fundamental level, the universe runs on chance. This was so bizarre that even Albert Einstein hated it. He famously said, "God does not play dice with the universe." But every experiment we've ever done shows that, yeah, down in the quantum world, the dice are always rolling. Okay, so this is all pretty fascinating, but you're probably sitting there thinking, why do I care about some fuzzy electron from 100 years ago? Well, the answer is that this abstract idea is literally powering the world around you at this very moment. The transistor, that little switch that's the beating heart of every computer, every phone, every device you own, it only works because we understand these quantum rules. Lasers, the incredible technology in MRI scanners that lets doctors look inside the human body. All of it comes from knowing how this strange, probabilistic world works. To put it simply, without uncertainty, you wouldn't have modern electronics. Period. So, in the end, Heisenberg's principle is so much more than physics. It's kind of a lesson in humility. It teaches us that nature has some secrets it will never give up completely. And maybe, just maybe, the wisest thing we can learn is to understand the limits of what can be known.